Bismillahirrahmanirrahim. Assalamu alaikum to my dear students. I hope all of my students and people who are watching me, you will be fine. Now today we are going to have our second year mathematics. In this lesson, in this video, we are going to cover our question number 7 of exercise number 1.1. This question is relating to the parametric equations. First, we will learn about the parametric equations. Which are the parametric equations? So, parametric equations are those equations in which two different variables are the functions of a single variable. For example, I am going to give you some examples of the parametric equations. If x is a function of t, so t is any variable, x is also variable, so y that is equals to f of t. Here x is the function of t and y is also the function of t. In this case, these two functions are representing two parametric equations. So I hope you got my point, which one are the parametric equations. Now we will have two parametric equations. By using these parametric equations, we have to prove the given condition. First one part, that is x is equals to a t square. I am going to give the name, that is 1, equation number. So second one is y is equals to 2at. This is equation number 2. Now by using equation number 1 and 2, we have to prove that y square is equals to 4ax, which is the equation of parabola. So first, what is the parabolic equation? Parabolic equation are those equations which are of the form y square is equals to 4ax. Or if you want to know about the parabola, what is a parabola? So parabola, that is same like this one. This is the parabola. So I give you example. When you see at the bridges, there are some shapes of like that. So this one is the bridge here and here, and this one is the bridge, and these two pillars are connecting to with each other like this rope. This rope is a parabola. So okay, now we have to show that these two equations are representing a parabolic equation. Okay, now we get started to solve our question. Now I have given the name, this one is the first, this one is the second. These two equations are depending on t. So one thing remember, if you want to find out your required condition, just eliminate the function on which two different variables are depending. For example, here x is depending on t and y is also depending on t. If we eliminate t from these two equations, then we will have required equation of the parabola y square is equals to 4ax. So here that is t square, here that is t. So I think it's easy to get the value of t from the equation number 2, because here is the square of the t and here it doesn't the square of the t, so it's easy from the equation number 2. So I write here from equation number 2, we will have t that is equals to y divided by 2a, because here 2a is multiplied by the t. If we shift 2a to the left hand side, then it will divide to the y. Now I am going to put this value in equation number 1, putting t is equals to y divided by 2a in equation number 1. Now here we put in place of t, x is equals to a in t that is equals to y over 2a whole square, x that is equals to a into y square over 4a square. Now I have separated the square of the y and of 2a. So now a will be cancelled by a. Here are two values of a, I have cancelled one. So 4a, if you multiply, if you take cross product, y square will be equals to 4ax. Now this is our required condition that we were needed. Now come to this one. Second one part, x is equals to a cos theta. Now I give name to this equation number 1. So second one, that is equation number 2. That is y is equals to b sin theta, represent the equation of ellipse. You know which one is the shape of the ellipse? Ellipse shape is like that, the egg. It can be like that. This is the shape of the ellipse. Now we have to prove that these two equations are making the equation of ellipse. Now look at this one. The equation that we have to make, that is x square over a square and plus y square over b square. If we shift from equation number 1, if we shift a to the left hand side, that will be x over a, and if we shift b to the left hand side of the equation number 2, that will be y over b. Now these two things are going to fulfill our requirement. So now I use these two equations. I write here by from equation number 1 and equation number 2. We will have x over a, that is equals to cos theta, and second one y over b, that is equals to sin theta. Now we will take the square, because there is also square even in our required condition. At the x over a there is a square, and at the y over b there is also square, and these two equations are added to each other. So at the single step we will take the square, and also we can add these two equations. So I write here squaring and adding. Both of these two things I am going to do in a single step. So x square over a square plus y square over b square, that is equals to cos square theta plus sin square theta. So cos square plus sin square, that is equals to 1. So we can write in the place of cos square plus sin square, that is equals to 1. And now this is our required conditions that we have proved. Now come to the third one part, that is x is equals to a secant theta and y is equals to b tan theta. Similar strategy that we have done in question number part number 2, here in part number 3 again we are going to use this strategy. So here we will use from equation number 1 and 2. So look at this one. If I shift a to the left hand side, it will be x over a, and if we shift b to the left hand side, it will be y over b, and we have required x over a and y over b. Just we have to write here, there is a squaring and adding. So it was the sign of the additions, that's why we said squaring and adding, but here is a sign of the subtraction. We will write here squaring and subtracting. So by using 1 and 2, I am going to give the name this equation number 1 and this equation number 2. So from 1 and equation number 2, so that will be x over a equals to secant theta, and second one y over b, that is equals to tan theta. Now because there are the squares on the x over a and there are the squares on the y over b, and also these two equations are subtracting to each other, so I write here squaring and subtracting. It will be x square over a square minus y square over b square, that is equals to secant square theta minus tan square theta. So secant square minus tan square, that is equals to 1. It becomes x square over a square minus y square over b square, that is equals to 1. Now this is our required conditions that we have proved. So I hope all of you got it very well. Inshallah, in our next video we will be doing our next questions of this exercise. So keep watching and don't forget to watch my YouTube channel. Visit my YouTube channel, that name is maths.counseling.